Hello guys, welcome to Friends in Tech Automation YouTube tutorial. We provide practical training on PLCs, SCADA and Industrial Internet of Things. And in our today's video, we want to learn about latching. What is latching and why latching is important part of PLC program. Because I know most process you need start and stop. For example, if you want to start a motor, you need to start a motor, and sometimes you need to stop a motor. If you want to start a pump, you need to start a pump, and you need to stop a pump. You need to start a conveyor, you need to stop a conveyor. You need to start a drive, you need to stop a drive. So most circuits and most programs must include latching circuit or latching program. Now, what is latching and why is it very important part of PLC program? Now, latching here, let's just describe what is latching in the first place. Let's just describe what is latching in the first place here. So latching, there are often situations where it is necessary to hold an output energized even when the input ceases. A simple example is when you want to run a motor. So you can start a motor by clicking or by pressing start push button. By pressing start push button. Then after that, you release your finger and motor will continue to run. Now, this circuit can only be broken by introducing a stop push button. So we say that it is a self-maintaining circuit in that after being energized, it maintains that state until another input is received. Now, until another input is received, mainly it is stop button, or it can be a proximity switch or a proximity sensor. Now let's look at an example here of a diagram of a circuit here. In this circuit here, we have MCB, we have contactor KM, and we have overload relay, or you can call it thermal relay. Then we have induction motor. We have induction motor here. Then we have stop push button and start push button. Now what happens here if I go to simulation mode? I'll just engage MCB here. Then I want you to observe this motor here, and I want you to check this circuit here. So in this ladder network here, we have OR, that is overload contact 9596. We have stop button, that is 1 2. We have start button or start contact, that is 3 4, and we have KM A1 A2, that is coil. It represents the coil. So what happens if I click on start here? If I click on start, I want to click it only once, just once, and I want you to observe the circuit there. So even after releasing my finger, you see the motor is still running. The motor is still running. Now, this scenario or this situation is what is called latching or hold on. It is latching or hold on. Why? Because even after releasing your finger, the output is still energized. The output is still energized. The contactor is still engaged. So we can stop this here by by two things. First, if we engage the stop button here. So if I press stop button, it will break this here. That's it. Again, I can hit here. Now, another situation how you can break this is when overload trips. So if overload trips, let me just trip it here. You see, the output will disappear. Let's just reset it. So the output will disappear. This is what is called latching. Now, how can we write latching in TI portal? So the first thing, open your project in TI portal. This is our project. Remember, we created a project called YouTube tutorial. We created a project called YouTube tutorial. You can check our previous video on how to create a PLC project in TI portal V20, and how to add power supply, CPU, and IO modules. Also, how to add communication modules. Now, after opening the project here, one fundamental thing is that don't jump to programming fast. Take your time to define tags. So if you open this folder PLC underscore 1 CP14 -3PN DP, where this PN is for Profinet, DP is for Profibus or MPI. Now, we have another folder called PLC tags. Now this folder here, this is where you need to define your tags. So it's always good or best practice to define your tags first before programming. All right, so just open show all tags. So you can open show all tags, or you can decide to create a specific tag for motor. So you can add a new tag table and define it. Instead of calling it table 1, you can define it motor tags, motor underscore tags table. So you can have a very specific tag table just for motors. Then just double click on it, so it is empty here. If you check this diagram here, we have start and we have stop. Those are two inputs, so you can define them here as start 1. So start button 1, start button 1. Then we can define another one as stop button 1 as well. That's it. And now you can define motor. Let's just call it motor 1. Motor 1, that's it. But now motor 1 is given an address I0.2. That is wrong because motor is an output. So you have to change operand identifier here to Q. Then we have to change address to 0.0. So change bit number to 0. Then that's it. So we have our tags here. This is very important. This is what is called tag table. So this is where you'll see all defined tags. And this is also very important here, this access. Your tags, the good thing, leave your tags writable and visible. Why? Because when you connect your TI portal or your PLC to SCADA softwares like Ignition from Inductive Automation or VTC Explorer, we'll need to write or read tags. So if you don't give this access here, writable and visibility, it means that we cannot write to that particular tag. So just check here. So anytime you want to use HMI, OPC UA, APIs, web APIs, you have to enable this here to writable and visible. It's very important. All right, that's it. Now the next step, we go to programs and open main OB. So OB, we said OB is organization block. In other programming interfaces and environment, it will be called POU, programmable unit or program unit. Then go to main here. So also we need to introduce emergency here. You know, it's always a good practice to introduce emergency stop in your system. So let's just include emergency stop. That's it. That's it. And we know emergency stop is an input, so this will be I0.2. So let's change operand identifier to I. This will be 0.2. All right, that's it. That's it. All right, that's it. So go to your main program here and start programming. So the first thing, introduce emergency stop. Now you have to be very careful here. One thing is, emergency stop is always normally closed. So when you hit the knob, it will change contact from normally closed to normally open. So I mean, you have to use normally open here. Why? Because it is always normally closed. So without doing anything, it will send a signal to I/O of your PLC. That means that this normally open will change to normally closed. When you hit the knob, it will change to normally open. That's why it is very necessary to use normally open here. So this here, call it emergency stop. That's it. Then introduce normally open for start. Why? Because start button is always open. Start button is always open, right? So just give this start button 1. That's it. Then introduce a coil here. to represent motor 1, and let's try to demonstrate this here. So to go to simulation and load your program. So here, of course, I think there's something running. I just stop this guy from running and check this and check this, then refresh, then load the program. Okay, you have to start simulation first. You have to click start simulation to start PLSim. All right, without starting PLSim you cannot load unless you have a real PLC. So by doing this here, we can go online, and we can monitor inputs and outputs. So I'll take my PLC to run mode. That's it, and I have it here. So emergencies always are closed, so I will just engage it here, always closed, like that. So this motor is only waiting for start. So the disadvantage of this here, this is like connecting having a wall switch and a lamp. So what will happen if I engage key I 0.0, the motor will go on. If I release my finger, the motor goes off. If I press, it goes on again. If I release, it goes off. Now that's a very big limitation. Why? Because imagine you are running a package line, a packaging process, so you can't stay there just holding start push button all the time. It's not logical, right? It's not logical. So what we'll do, we'll introduce a latching here. So we need to bypass this start button 1. So to bypass this start button 1, we have to use auxiliary contacts of this coil motor 1. Auxiliary contact, it's contact. So I'll just introduce a branch here, open branch, then I'll introduce normally open, then I'll introduce a closed branch, then this here we need to bypass this. So to bypass this, you use motor 1. That's it. And let's download the program again. I'll take it to stop mode. Then let's download the program again. Load. That's it. Then take CPU to run mode. That's it. So see what's happening here. So emergency stop is always on. That's it. So if I click start button 1 only once, even after releasing my finger, you see it's broken, but motor is still running. Why? Because we have introduced a bypass here. So this is what is called low, hold on, or latch. All right, this is hold on or latch. Very important. So this is very important. Most of your networks will always start with this. Most of your networks, whether you want to start a drive, you'll use this. If you want to start motors, you'll use this. If you want to start your pump, you'll use this. If you want to start your soft starters, you'll use this here. So latching is a circuit. It's a very important circuit. Now to stop this here, I can use emergency stop. So if I press on emergency stop, it will break the circuit. Pop. That's it. But I don't want to stop the circuit using emergency stop. It's not best practice. Emergency stop should only be used in extreme cases. So you need a stop push button to break the circuit. So introduce a stop here, normally open. Why? Because stop button is always closed. But it depends here, by the way. Here it depends because our next topic is on flip-flops. So when using SR and RS flip-flops, then we'll have to really be careful with stop buttons. So I mean, I can decide to use normally close here, but you have to be very careful when deciding whether to use normally open or normally close. So this will be stop. That's it. Then I have to load this program again. So I stop my CPU, then load the program. That's it. That's it. So if I magnify this here, I want you to see this clearly. Let me take it to run mode. There. So there you have it. So you see here, emergency stop is always on, then start button 1, stop button 1. So this circuit here is just waiting for signal from from start button. It's only waiting for signal from this here. Once it receives the signal, motor will be engaged. So now you can go here, PLC, then you can click start. That's it. So even if I release my finger, what happens? Motor is still running. So the only way to break this circuit here is by clicking stop button 1. So you can either click stop button 1 or emergency stop. So let's just click stop button 1 here, and the motor will stop. So motor has been stopped. Again, you can start it using that. You can stop it using this, using that, and you can stop it with this here. So this is what is called latching. I hope this is very clear. It's very important circuit, and I hope this is very helpful. So thank you for watching this video. Kindly subscribe to our channel, Friends in Tech Automation. Share our videos. Thank you again.